Let's talk about insert delete get random all of one. So you have a class you need to implement, and the implementation for the time complexity is all of one. And what you actually need to do is, if you want to remove, right, this is actually the difficult thing you have to consider. And I'm going to write down, and then you will follow along my strategy. Okay, so I do need an integer list, right? So I'm going to use array list integer. I'm going to throw list, and I also need a random, so random r, and then I need a hash map. So my key is actually storing the value in the list, and the value for the map is actually storing the index in the list, right? So I'm gonna put map, and map equal to new hash map. This equal to new array list. R equal to new random, and for the insert, I'm going to insert a value into the list. If the value already in the list, which means map.contents can find it, right? So map.contents key val, if you can find it, then you have to return false. And if you cannot find it, I mean, you can just add into the list, right? And also, okay, map also have to add, right? Map.put, and then I'm going to put val, and then the current position is this.size, right? And I need to return true at the end. Alright, so let's talk about GetRandom first. So GetRandom is actually pretty easy. So I'm going to say list of get, and then r dot next in, and the size of the list, right? And this will give you a random value that depending on the r, right? So remove is actually harder to do it. So it, since the number in the list is unique, so you can actually know if you find a value in the list, it's not at the end of position. You can swap. You can swap the value with the value you want to swap, right? And then you just did the last one. That will cost you all of one, right? And they just stop recording. So if the value is not in the map, I need to return false, right? If map contains key val is not in the list, then I will return false. Oh, that's why I need to remember my position. So I'm gonna say map.get val. So the position is actually determine the index in the list, and if the position is not equal to the list dot size minus one, it's not at the end, then I need to swap, right? So I'm gonna say so I need to swap, right? So the last one is actually equal to so this one is the current last one right now, but I need to swap with the position one, right? With the value one, right? Because I need to delete this. So list.set position, and then last one value, and this will determine. I mean, this will swap already, but I also have to what? I also have to put change my value and then position in the map, right? Put last one and the position, right? So everything is pretty standard, and definitely we need to remove the value, and also list remove the last one because we already swapped, right? Oh, sorry. And then at the end we just return while return true, right? And this will be the solution, and they just run it. Okay, I do have a typo. Are equal to new random. So okay, so you have to use the Java random one. So Java random R, and then the Q new Java random R, right? Oh, maybe I just forgot a parenthesis. Maybe this was the problem. So let's just run it again. Yes, I forgot the parentheses. Alright, let's just run it. Alright, here we go. So let's talk about time and space complexity. So definitely the time is actually all of one, right? All of one, all of one, all of one, and all of one. And the space is actually all of n, right? You need to store the number of elements in a map and a list. And the R is not taking any space. So this will be the solution. And if you feel helpful, subscribe, like if you want it. Alright. And I will see you next time. Bye.